Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, is that dolphin talking to a robot? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the ocean to find out about one startup's mission to use robots to monitor the marine environment. Before that, please remember to like or rate this episode and leave us a review if that's something you can do on the platform you're listening on. And don't forget to enter our t-shirt competition for a chance to win your very own Robot Talk t-shirt. All you have to do is share your favourite episode on social media and tag us at Robot Talk Pod. So, without further ado, let's get on with this week's interview. I recently had a great chat with Ffion Llewellyn from Oshen, all about seafaring robots and ocean sensing. This week, I'm speaking to Ffion Llewellyn, an engineer at Oshen working on autonomous microvessels for remote ocean sensing. Hi Ffion, lovely to have you on the podcast.
Hi Claire, thank you so much for having me. I'm excited to discuss Oshen with you.
Likewise. So Oshen is a startup that launched in 2022 with the aim of developing aquatic robots that can collect data about the ocean en masse. Can you tell me a bit more about Oshen and what the company is working on?
Yeah, definitely. So we're an early stage startup from Imperial College London, and we're developing microvessels to collect this remote ocean data. A bit about the microvessels. They're about 1 meter long. They use wind for propulsion and solar energy for their electronics. And if you'd like to visualize them, they're kind of like mini sailboats with these rigid wing sails and a self-righting lead keel so that they cannot capsize. Our aim is to have a fleet of fully autonomous microvessels for collecting ocean data that can go wherever you want them to go, or to station keep if that's what you need. And the idea is that they're small and simple, so that there's the novel hardware design, which gives us some key advantages. Firstly, the wind power means that they can provide persistent monitoring over long periods of time. And secondly, the small design results in affordable and easy deployment so that they can be deployed in large numbers to provide good spatial coverage of this data. And Oshen began when my co-founder Anita wanted to do a world first and complete the Microtransat Challenge, which is a competition to get a fully autonomous sailboat across the Atlantic without any communication.
Wow.
While she was building the path planning algorithm, she found that the data in the middle of the ocean is actually not very accurate at all. So if I fast forward to where we are now, we've had various grants, and we've built 2 functioning prototypes, which have completed day-long sea trials collecting metocean data, which is things like sea surface temperature, air pressure, wave data, and also acoustic and visual data in up to force 6 conditions, which is around 30 mile per hour winds and up to 4 meter waves.
Wow. That's awesome. So they're wind powered. So I'm guessing that means they're sitting at on the surface of the ocean rather than being like submersible.
Yeah, so they just sit on top of the sea, and they've got a big sail and an anemometer which sits at the back, which takes wind readings, strength and direction, and that's what helps us to set the angle of the sail. Okay,
cool. Yeah. And then how do you communicate with them once they're out there? How do you control where they go?
Yeah, so we have a few ways of doing this. When we do our initial testings out in Carnarvon Bay, we've got a remote control, and we can put this into manual mode, and we can check that the sail and rudder move where we want them to go, and the vessel behaves as we want it to behave. But further from that, we've got satellite control of it, so we can send it waypoints where we want it to go, and then it can autonomously sail to those different waypoints.
Okay, fantastic. So in your role at Oshen, you've been focused on integrating and testing sensors on these ocean microvessels. So you've mentioned a couple already, but what other kinds of sensors are you kitting them out with?
Yeah, so if I break this down firstly into the acoustic and visual side of things. We have just finished an Innovate UK project where we've been testing the feasibility of using our microvessels to monitor marine mammals. And this has involved integration of hydrophones, which was quite interesting to start with. There was no real precedent for how we're meant to do this. We weren't sure if we were meant to tow the hydrophones behind the vessel or mount it onto the vessel, but we wanted to minimize the drag of our vessel firstly, and also minimize the background noise on the hydrophone from our microvessel moving through the water. So we ended up integrating 2 hydrophones. One was a system from RS Aqua, and another was a cheaper hydrophone called a Hydro Moth. And we also integrate a camera on board for visual data collection, which this is something we hope to use for collision avoidance in the future.
Right.
After lots of initial testing, we collected background acoustic data and gathered all this to get feedback from experts. And after testing in Cardigan Bay, we successfully collected audio, whistles, and echolocation of bottlenose dolphins during testing, which is
cool.
Really exciting.
Yeah, awesome.
So the project was successful, and now we know that we can collect the audio. There are exciting things we can do with this in the future. One of the things we have to think about is our power usage. So we can't run these systems 24/7 off the solar energy. Further down the line, we'd like to integrate some machine learning on board so that this could pick up the interesting noises and send messages if a marine mammal is in the area. So yeah, the last year has been a big focus on the acoustic data side and also on the actual functionality of the microvessels. But we did also start on the metocean. So I said we had the anerometer, which gives us the wind speed and direction, helps our microvessel to navigate. And then we've got temperature probe on the keel to get the sea surface temperature, another temperature probe on the deck to get air temperature and also air pressure sensor.
Okay.
We're hoping to integrate some higher sensitivity sensors soon to gain more accurate data, to improve weather forecasting and to validate satellite observations. Another thing we've been working on is initial testing with accelerometers to gather wave data, but this is more complex than we originally thought due to the way that our microvessel interacts with waves. So we are doing some validation work on this actually in the next few months. This data is transmitted over satellite to our dashboard for real-time monitoring, so we can track our microvessels and analyze the data that they are collecting. And then finally, we have just kitted out a second prototype for testing with a Maker Boy, thanks to Wayne. It's a standalone system which measures significant wave height, sea surface temperature, air temperature and pressure and photos, and transmits all this data over satellite again. And we can view this on our dashboard as well.
That's really cool. It seems like there are a lot of different possible applications for all of this data that you're collecting.
Yeah, definitely. I think the last year has been a lot with the marine mammal side of things, and this has different uses as well. And then right now we're hoping to focus more on the weather forecasting side of things.
And I guess also like in a longer term capacity, you could be, monitoring the effects of climate change and stuff like that.
Yeah, definitely. I think having our boats out there and having them be able to, right now you've got these drifting buoys that go over and they go with the current, so you can't tell where to go and to collect the data. But if you've got a microvessel and you can tell it where to go and you can observe a storm coming in, hopefully it'll provide some much more accurate data for predicting things like climate change and the weather and all sorts.
Yeah. It's a really cool project. I love the idea of this kind of little fleet of tiny robots, traversing the oceans and collecting all this data.
Yeah, that's the dream, to have a network of sensors out there all collecting. And
yeah, I'm sure that's easier said than done. There's probably quite a lot of challenges involved, from scaling up from a couple to, I don't know, are you imagining hundreds in the future? Thousands?
Yeah, definitely. We have, I think in the next few months, we're hopefully getting a fleet of 10 of them. We'll definitely encounter these problems as we go. But it's super exciting. And the hope is that we'll have lots of them out there and working on different applications and collecting lots of data.
Yeah. So you recently graduated from Imperial with a master's in aeronautical engineering, and now obviously you're working in a startup, kind of in the real world. So how does the reality of building ocean-faring robots compare to the theory? Have you encountered any unexpected challenges or roadblocks?
Yeah, I've definitely learned a lot in the last year since graduating. I think the big one is that in practice, things don't always go to plan compared to the
Sure.
theory, and you have to leave contingency time for this. I think, in particular, building these micro vessels that need to survive the ocean. A big part is robustness, protecting
Yeah.
components and waterproofing sensors, trying to stop them from rusting, just trying to make it as robust as possible, really. And we have been learning as we go. We have encountered some roadblocks, sometimes annoying. A night before a sea trial, everything's working perfectly. And the next morning, some due to likely some water ingress, some components stopped working and
Mm.
the whole system is down. Um, but we have been making the system more robust, and we have just had a full redesign of the electronics. So this will definitely improve
Okay.
things. But yeah, it's definitely, from leaving university, definitely taught me to be a lot more patient and has improved my problem solving skills.
Yeah.
But it's definitely something I saw during university as well. In my final year, I ran experiments and things very rarely, work well the first time. So part of the job is to find other solutions. And it definitely makes the milestones more rewarding.
Yeah, definitely.
Yeah, so it's a super exciting project to be working on.
Yeah, it's really cool to be able to kind of finish your studies and go straight into working at a startup where it's kind of constant action and challenges and new things to try out.
Yeah, definitely. It's been quite lucky, I think. And as quite a small team as well, it's very hands on and I get to do different things all the time. And part of it is as well as going out to sea and testing these micro vessels. So, um, yeah, it's very varied and I'm really enjoying it.
Yeah. You don't get seasick, do you?
um, Only on one sea trial, I had to sit down for a while, and when you're concentrating on the boat, sometimes you can start to feel a bit ill. But
Yeah.
when you're out in quite rough conditions, yeah.
Yeah. Yeah. I mean, I get really seasick, so I probably couldn't do what you do.
So,
Talking about robustness, though, obviously being solar and wind powered, in theory, these micro vessels could kind of just wander the seas indefinitely. But I'm sure that over time they'll need repairs or they'll, have issues. Is there a plan of like how long they might be out at sea continuously and will there be this is I'm thinking probably quite a long way in the future, but they have like a schedule to come back and dock for repairs or that kind of thing.
yeah, definitely, it's something we'll definitely have to consider, and it is something we're already considering. I think our baseline plan for immediate future is to have one of these out there for a month.
Mm.
And down the line, we can have them out there for 6 months to a year, but it'll definitely have to as well. We're calling the boat we've got right now Generation 2, and the
Mm.
design of it will definitely have to change, to be able to fit more solar panels. They have got battery backup, but we'll definitely have to change the design as we go, and it'll definitely be a bit of a learning curve. And they definitely will have to come in at some point. But the benefit of them as well is that they can come back, and they won't be, you know, adding pollution to the ocean. So that the
Mm.
fact that they can sail back and we can do repairs is definitely a benefit to, and we've got redundant tracking on them as well. So yeah, compared to other methods of collecting data right now, it's definitely a huge benefit, really.
Yeah, yeah, that's a really good point. I hadn't even thought about the kind of the potential for ocean pollution if they got stuck out there or broke or whatever.
Yeah.
So, what do marine animals make of these vessels if and when they encounter them?
Yeah. So I think they actually seem very curious. We've had a pod of dolphins visit us in Carnarvon Bay where you wouldn't normally expect them to be.
Hmm.
Um, and they were jumping in and out of the water in front of the micro vessel, and we caught them from the camera on board the micro vessel.
Cool.
And then when we collected the audio, they seem to be whistling a lot, but they seem to be echolocating, which is where they locate objects around them, and they seem to be doing this quite frequently.
Hmm.
Um, yeah, after speaking, to some scientists, they seemed that they were very curious about the microvessel, which is great to know that we don't disrupt them too much. As obviously we want to be non-invasive, we want to be tracking them and seeing how they're moving. We don't want to be harming them or anything like that.
Yeah, definitely. I mean, dolphins are known for their kind of inquisitive nature, I suppose. So it's not surprising, perhaps, that they're one of the first animals to come and check out what you're doing.
Yeah, definitely. And the draft of our boat, it only goes down about 0.8 meters probably into the water. So they're not big pieces of equipment. Yeah, and that's one of the key things really. They're small and easy to deploy and hopefully non-invasive to these animals, and we can just monitor them without causing any damage.
Yeah, and they're kind of on the sort of scale of like other marine organisms. Okay, obviously, like marine organisms range in size from like tiny to massive, but like to a dolphin, they're kind of that sort of size of something they're used to seeing, I guess.
Yeah, definitely. But they do make some quite interesting noises that we picked up. It's been quite fun to go through.
Yeah, definitely. I hope sharks wouldn't see the microvessels as prey.
Yeah, me too. Although they're quite hard, so I'm not sure that. Yeah, not quite sure how that would go, but yeah, hopefully not.
Yeah.
So find out about that in the future.
Yeah. There's definitely going to be some trial and error to be had as you explore the ocean further.
Yeah, it's definitely part of the process, and it's what we've been doing so far. To be honest, it's all trial and error and figuring it out, and it's part of the process. But it's good fun. When you hit some good milestones, it's very rewarding.
Yeah, definitely. I mean, it sounds like a lot of fun, and I'm excited to see what Oshen gets up to in the coming years and decades. Ffion, it's been fun chatting to you today. I've been talking to Ffion Llewellyn, an engineer at Oshen. Thanks, Ffion.
Thank you so much, Claire.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast and leave a review to let us know what you think. And make sure you check out our social media channels to see a photo of one of Oshen's microvessels during a sea trial in Carnarvon Bay. We're at Robot Talk Pod on all the socials. Next week, I'll be speaking to Carl Strathen from Edinburgh Napier University, all about humanoid robots, realistic robot faces, and speech. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.